How often have you attended a meeting or read a report where a number is presented that indicates what the performance of something was for the current month, but just that one number alone? Now, depending on the context, that might be okay, but in the scenarios I'm thinking of, the target audience was being informed about how well things were going regarding a process, program, or the overall organization. If everybody in the target audience is well informed about how things have been going in the past for quite some time, and knows specifically what the numbers have been, that might also be okay. But in my experience, that's usually not the case. Without knowing what the number was for the previous month, it's difficult to impossible to know if that one number being reported is higher or lower. It's a little bit better when a comment is made that this one number is higher or lower than the previous month, but even better, the specific number from last month is stated. Now you can calculate in your head how much of a change there is. Even better yet, both numbers are given, and the presenter or report does the math for you. Maybe you're even told what the percentage of change is from the previous number. Regardless, it is really hard to make much of an assessment of how things are going with just two numbers. This is sadly a very common problem, so much so that we have a tool specifically designed to remedy this problem. It is one of the most basic and important data visualization tools we have in the quality toolbox. It's called a run chart. The run chart is the graphical display of a set of data points that are shown in the order in which they were collected over a period of time. The customary way of showing the data points is with the value of the number being reported on the vertical axis, also called the y-axis. Usually the lower values are at the bottom and the higher ones reaching upwards. Time is on the horizontal axis, also called the x-axis. Usually the most recent point in time is shown to the right side of the graph, and the oldest data is on the left side. Let's look at an example. Suppose we have a community where they have formally designated a STEMI system of care. They formed a consortium of all the major players that deliver the emergency care. It has all of the STEMI receiving hospitals that do cardiac caths, and both the ED and cardiac cath lab teams are represented. ED representatives from all of the referral hospitals that send STEMI patients to the receiving hospitals are also represented. All the ambulance services and non-transport medical first response agencies have a rep there as well. Emergency medical dispatch centers that manage STEMI patients before hospital arrival or during interfacility stat transfers from the referral hospitals to the STEMI receiving hospitals are all represented. This acute STEMI care consortium meets every month to review performance data on various aspects of their STEMI system of care. One of the key performance indicators that they focus on is the symptom onset to device time. It's their best approximation of total ischemia time, which is how long an episode of myocardial ischemia lasted before the coronary artery was opened. Research shows us that the longer the period of total ischemia lasts during a STEMI, the more of the myocardium is lost and the worse the outcome. Time is muscle. So the consortium is trying its best to do things that reduce that symptom onset to device time. So they need to know if the performance of the system is getting better or worse. They need to know if the changes they have made to the system of care are making an impact or are things staying about the same. They all submit data to a clinical registry database which collects and analyzes information from all the STEMI cases at all of the STEMI receiving centers. Shortly after the end of each month, the elapsed time on each STEMI case from acute symptom onset to the opening of the artery in the cath lab is calculated. All of those elapsed time values are put together to calculate an average. A run chart is then generated from that system-wide average result. The data points are connected with a simple line. Looking at the last 3 years of data with monthly data points, we get this run chart. Being able to see the data in this graphic format, a data visualization, gives us a much better idea of how things are changing over time throughout the region that the consortium serves. One of the other issues with run charts is how often to add a new data point. We often think in terms of each day, week, month, quarter, or year. In general, I suggest you add new points as often as you have enough cases to be representative of how well the process overall is working. Just 1 or 2 cases is really not enough. Hundreds is much more than needed. 10 or so is probably a good place to start. So if you consistently have around 10 or so cases a week, I'd add data points weekly. If it takes a month to accumulate that many cases, then add a data point monthly, and so on. In a separate post, I'll talk about how you might address this challenge in a low case volume scenario. The advantage of having new data points added more often is that you get to detect changes in performance sooner than later. If something's going wrong, it's better to know as soon as possible so you can intervene. If something is getting better, you can try to lock in that change as soon as possible to make sure that progress is sustained and maybe even spread it to other places. It's a bit of a trade-off. Larger groups of cases for each data point add some precision to the picture of how things are performing, but you do not get to see changes as quickly. Smaller groups do not give as precise of a picture of how things are going, but you can detect any changes sooner. So 10 or so cases per each time period can give you a nice balance. It's okay that some periods have a few more and other periods have a few less. If the average is around 10 or so, you're probably in pretty good shape. You can also consider adding a new data point based on a fixed number of new cases. Instead of adding a new data point at regular time intervals like each week or month, you add a new data point with each set of new consecutive cases. You might choose 10 cases for calculating each data point. Once you decide how many cases per data point, stick with that number of cases per data point. This approach might be particularly helpful when you have seasonal swings in the number of cases. With your run chart, you get a clear view of how things are changing over time. It lets you see if things are generally getting better, worse, or staying about the same. These types of assessments get us into the realm of trends. What exactly is a trend? How much of a change is needed over time to be considered a trend? Those are extremely important questions, as it will influence your interpretation of the run chart and influence your management decisions about how to react to the information on the run chart. We'll take up the issue of assessing trends in the next post.